So moving to the next question, children, 33rd question. The potential difference between points A, B of the adjoining figure is. So identify A and B. Here is your A and here is your terminal B. Let us drop the simplified diagram for this. A, one more resistor, and here it is B. Here both resistors are given as 5 ohm and 5 ohm. From B to C, one more resistor is connected. B to C, you have one more resistor, 5 ohm. So, together 1, 2, 3, all the 3 resistors are connected in series. So, instead of drawing like this, I drew it something in a straight way because all the 3 are connected in series. And between the terminals A and C, a 2 volts potential difference is applied. Where is A? Here is your A and here is your C. So, between A and C, we observed that a potential difference of 2 volts is applied. So, this part of the circuit is drawn. Now, coming to the bottom part, again from A to D, a resistor, from D to C, 2 resistors are connected. All together, they are again connected in series. So, let us plot the same. One resistor 5 ohm from A to D, and again from D to C, you have 2 resistors connected. Okay, so this must be the simplified diagram, circuit diagram for the above picture. So what you are observing is all the 3 resistors are connected together in parallel to the 2 volts battery, and again these 3 resistors are further connected to the parallel to this battery 2 volts. So between these 3 as well as these 3, same potential difference is being maintained. So, same potential difference is maintained indicates that as there are equal resistors, the potential difference between them is also divided equally among them. So, how much is the total supply? 2 volts. So, this 2 volts must be divided between the 3 equal resistance equally. That means 1/3 will be going to here, 1/3 will be going to here, and 1/3 will be going to here. 1/3 of total 2 volts is equals to 2/3 volts. So, here 2/3 voltage supply, here also 2/3 voltage supply, and here also we have 2/3 voltage supply. I hope the picture and the diagram is clear, children. So, we are not bothered about this. Though here the values are given, you are only asked to find out the potential difference between A and B. So, let us focus on this. So, between A and B, what is the total potential you can identify, children? The total potential between A and B, that is VAB, is found to be potential from this end to this end and again between this end to this end, 2 resistor, that is 2/3 volts plus 2/3 volts, or the potential difference applied across VAB equals to, here you have LCM is 3 and 2 plus 2. So, this is found to be 4/3 volts. Hence, the correct option is option C, that is 4/3 volts. I hope the concept is clear, children. So, identify where you need to find out the potential difference and then do the sum accordingly. Moving to the next question, 34th. The current in the adjoining circuit will be. So, here some circuit is given and you are asked to find the current. So, here the current flow of current is also given. One here indicated with the letter I. Of course, the same battery, here also you can take this as I, and the potential difference between them is given as 2V. And this is the circuit. And in this circuit, if you observe, 3 resistors are connected as shown in the figure. Among the 3 resistors, we can see that this 30 ohm and 30 ohm together are connected in series combination. If 2 resistors are connected in series combination, together the resultant will be equals to summation of those 2. So, what is the summation of 30 and 30? It will be giving you 60 ohm. Okay. Here you have 30 ohm and the resultant you have again 60 ohm. Now, let us draw the simplified circuit diagram for the above circuit. So, how would it look like? Here is your 30 ohm. Here is your 2 volts battery. And the simplified form for that is you are getting here as 60 ohm and current, some I amount of current is flowing across the circuit. So this is how the simplified circuit may look like. So this is 60 ohm. So now if you observe this carefully, these two resistors, how are these two connected? The two connected parallel to each other. So when two different resistors are connected parallel to each other, then the effective resistance will be R effective equals to, formula is R1 R2 by R1 plus R2. What is R1 here? 30. What is R2 here? 60. R1 R2 by R1 plus R2. R1 plus R2 means 30 plus 60. So simplifying this, how much are you getting, children? This is equals to 30 into 60 upon 90. So simplifying, this 0 goes off, 3 3s 9 and this goes 20 times. Hence, the effective resistance between these two is found to be 20 ohm. Clear? So, let us now draw the last simplified circuit for this. And this is something like this. Effective resistance is 20 ohm. Some I amount of current, 2 volts battery supply and hence the same I amount of current. In the given circuit, voltage supply is 2 volts, resistance offered is 20 ohms and the current is I. So, what is the relation between the voltage, potential difference, resistance and current? You have to go with the Ohm's law. What is Ohm's law? V is equals to IR. And in order to find out the value of I must be equals to V by R. Substituting the given values, V should be taken as 2, R should be taken as 20. So, simplifying further, you will be getting this goes 10 times. So, finally, you are getting it as 1 by 10 amperes. So, how much current is supposed to be flowing across this loop, children? It is 1 by 10 amperes. Hence, third option, that is 1 by 10 amperes is true. Are you getting me, children? Okay, so moving to the next one, that is 35th. Here, a circuit showing 5 resistors are connected as shown in the figure and you are asked to find the equivalent resistance between the 2 points X and Y. So, let us identify the 2 points, point X as well as point Y. Okay. So, fixing these 2 points, you have to simplify this circuit and to find the effective resistance. To find the effective resistance between that, so clearly X is connected to some other terminal and Y is connected to some unknown terminal. So, let us name those terminals, one as A and other as B. So, now we can observe 4 different junctions and for the 4 different junctions, 5 resistors are connected. So, let us try to draw the simplified circuit diagram for the given picture. It somehow looks like this. So, let us fix the 2 points. One is X and the other is Y. So, what are the rest points? A and B. 2 more junctions are also being observed. One is A and other is B. Now, let us draw the circuit diagram once again. So, here very clearly you can observe that the terminal X is connected to the point B. So, here X is connected to B. How much is the resistance? 10 ohm. Done. So, this part we have cleared. Now, moving further, X is also connected to A with a resistance of 10 ohms. X is connected to A with a resistance of 10 ohm. And now, A is connected to B by a resistance of 20 ohms. A is connected to B using a resistance of 20 ohm. So, this part is done and this part is also done. Now, you are left with 2 more resistors. B is connected to Y with 10 ohm resistors. Where is B? Here. B should be connected to Y using a 10 ohm resistor. And now, this is also clear. The only left is 10 ohm between A and Y. Between A and Y, one more resistor, that is 10 ohm is connected. So, this must be the simplified circuit diagram for the given picture and here you have to find the effective equivalent resistance between X and Y. If you observe this picture carefully, it somehow looks like a Wheatstone bridge, 5 resistors, some bridge-like structure having a 5 resistors. So let us name these as 5 resistors at this size P, Q, R and S. Okay. If in a Wheatstone bridge, we know that if P by Q equals to R by S, we can say that the bridge is balanced. So first of all, let us check whether the condition is satisfied or not. So what is P by Q? P you have 10 and Q also you have 10 and this is found to be 1 ohm. Similarly, down you go, R by S. R is 10 ohm and S is also 10 ohm. Here also you are getting 1 ohm. From these two relations, you can clearly say that the condition P by Q must be equals to R by S. So, whenever P by Q is equals to R by S, we can say that the bridge is balanced. So, when in a balanced Wheatstone bridge, we know that the effective resistance through the galvanometer is ignored. So, no current is supposed to be flowing through this resistors because the bridge is balanced. So now let us draw, as there is no current across this, okay, you can eliminate this resistor and let us draw the simplified circuit diagram for this. Now the simplified diagram somehow looks like this. This is X and this is Y. 10 ohm, 10 ohm, 10 ohm and 10 ohm. So now very clearly you can see this 10 and 10 are connected in series combination and hence the resultant would be 20 ohm. Here also 10 and 10 connected in series, the resultant would be 10 ohm. The next part will be, here is your X, up you have 20 ohm and down also you have 20 ohm. And this is your terminal Y. So, very clearly we can see that two equal resistors, each 20 and 20 are connected parallel to each other. When two equal resistors are connected in parallel to each other, the effective resistance would be R effective is equals to R upon 2 because 2 equal, so R by 2. So, R is how much? 20 upon 2 and found the value as 10 ohms. Hence, the correct option among them.